Getting something as tasty as maple syrup from a tree might seem like magic, but it's actually all based on science. Discovering the biology, chemistry, and physics behind maple farming can help us unwrap the mystery of maple. Naturally, we'll start with the leaves. Through photosynthesis, energy is changed into sugar, a food source for the tree, which is stored in the branches, trunk, and roots as starch. In the spring, some of the starch is turned back into sugar and added to the sap. Taking energy and turning it into food is the opposite of what you do at lunch when you eat, then go out and run around. You're turning food into energy. In the fall, when the leaves turn orange, red, and yellow, the process of photosynthesis is done, and soon the leaves fall from the tree. But they've done their job storing energy in the form of sugar and starch in the tree. Gravity makes the leaves fall, and it also helps farmers gather the maple sap. A network of plastic tubing allows sap to flow downhill toward a gathering tank or even to the sugar house itself. If the farm slope isn't steep enough for gravity to do all the work itself, a vacuum system can help pull the sap toward the sugar house. A vacuum is created when air and sap is pumped out of one end of the tube. That makes atmospheric pressure push from the other end, just like when you suck your drink through a straw. This keeps sap moving through the tubes more efficiently and draws more sap from the tree. And it's so much easier than gathering buckets of sap. Pressure is also at work inside the tree itself. A tap is a hollow tube inserted into the tree to provide an exit for the sap under pressure. Back and forth changes in temperature from below freezing to above freezing first fills the tree with the water that becomes sap, then builds up pressure inside the tree. That's because when branches of the tree freeze, gases in the tree contract. That develops negative pressure, a vacuum in the tree pulling water into the tree from the ground. When the tree warms up, the gases expand. That creates positive pressure, pushing sap out through the taps and into the gathering buckets or tubes. Temperature is very important in many phases of maple production. Without the proper range of temperature in the trees, sap won't flow. That's why maple production centers are in the northeastern United States and in Canada. Maples may grow elsewhere, but the weather patterns aren't right. After the sap is gathered, temperature still plays an important role. When water boils, it begins to turn into steam. The boiling temperature of water varies above and below 212 degrees depending on your elevation and the current barometric pressure. A maple producer needs to boil water to determine the current boiling point each day. When sap boils at 7.2 degrees above the current boiling point of water, it has become maple syrup. By then, some water in the sap has turned to steam and filled the sugar house on its way out the openings in the roof. Maple syrup is bottled when it's hot, at least 180 degrees. That way, the heat in the syrup will kill any bacteria and fungus present in the syrup, bottle, or air, so the syrup will not spoil while sealed in the bottle. If the maple producer continues to boil the syrup, a variety of other maple products can be made. A delicious product called maple cream is made by boiling the maple syrup until it is 23 degrees above the current boiling point of water, allowing it to cool to 50 to 80 degrees, then stirring it vigorously. Maple cream is spread on toast or sweet rolls. At the higher temperature of 32 degrees above the current boiling point of water, the thick syrup can be molded into maple candy. It's often poured into a mold shaped like maple leaves. It cools until a sweet treat, much like fudge. At even higher temperatures, the thickened caramelized sap can be made into maple sugar. It can be granulated into what you would put in your sugar bowl, used in cooking, or heated and spun into maple cotton candy. Evaporating the water out of maple sap is the longest and most expensive part of maple production. So, many producers remove as much water as possible before they begin evaporating. Something called a reverse osmosis machine will commonly remove 75% of the water from sap. The machine puts the sap under pressure, forcing it through a very fine filter. The filter catches the ester molecules and the sugar that creates the maple flavor. These esters and sugar are larger molecules, like minerals, that the tree roots have brought up from the soil into the tree's sap. This collection of molecules is what gives maple its unique flavor. The concentrated solution of maple flavor is thus separated from much of the water, which is made of smaller molecules that will fit through the filter. This concentrated sap is much more efficient going through evaporation. This is important because it takes between 40 to 45 gallons of sap to make 1 gallon of syrup. The rest is water. The percentage of sugar in the sap determines that ratio. Regardless, maple producers can save a lot of fuel by using reverse osmosis. Now that you know the science behind the magic of maple, maybe you'll want to experiment on the maple trees in your yard. We'll be glad to help, and the rewards for success are sweet.